Hi everybody, here's a quick video on permutations versus combinations. First we're going to have look at these two questions and figure out which one is which. This is going to be a no calculators video. We have an 11-person organization that needs to choose a president, vice president, secretary, and treasurer. No person can hold two positions. How many ways can these positions be held? Versus a 4-person committee being elected from an organization's 11 members. So it's 11 and 4 no matter what, but which one's permutation, which one's combination? I gave you a little hint in the typeset, and we're going to talk about that. The top one has president, vice president, and secretary, and treasurer. Do you care which one of those you are? Well, yeah, I don't want to be president. That's too important and stuff, and I certainly don't want to be secretary because my handwriting is messy, so it definitely matters. There, the order matters. So order matters because it matters which position you get, because it's distinct positions. Distinct positions. I don't know how to spell positions. Positions. And my hint here is the P for president. President, vice president, secretary is a permutation. So we're going to do permutation. We have 11 things, and we're ordering 4 of them. And then down here, it's a 4-person committee, which means all 4 of you are equal, and it doesn't matter who's who. There is no president, vice president. It's just everybody's the same. So this one is going to be like this. We're going to go ahead and do number 1 first in 2 ways. We had agreed that it was 11p4. I'm going to write down the formula, which if you're not using your calculator, this is one of the best ways to do it first. NPR, like National Public Radio. N factorial, n minus r factorial, which I don't really like this formula, but we'll talk about that in a minute. Okay, so here we go. Now we're just going to plug in numbers and talk about them a little bit. Not very much, though. 11 minus 4 is our denominator, factorial that. So this is 11 factorial over, what's 11 minus 4? That's usually 7, right? 7 factorial. Okay, and I'm going to write that below because I want tons of space to write all this lovely stuff out. You know what factorial means, so we're going to just keep clicking here. All right, so we've got our numerator done rapidly. Now we're going to do our denominator, and I'm going to place it right over here, and look what happens. We've written everything out, and we've got all this stuff that we can cancel, which means less multiplication, which is good, don't you think? All right, no calculator, but let's not cry. I'm going to break this up into 2 little nice groups and then deal with it from there. 11 times 10, there we go, times 9 times 8. Those are things that should be in your head. And then I'm going to use that distributive property. Here we go on the distributive property. Which I have written kind of backwards from the way you usually see it, but it shouldn't really matter. 72 times 100, that should be pretty easy, right? And then 72 times 10, 720. You add those 2 up, and you get 7,920 different ways to, or different president, vice president, secretary, and treasurer arrangements that you can have. Let's move on to the next one. Actually, I want to show you a different way to do this one, so hold on for just a second. Whenever something's a permutation, you can actually just use the general counting principle, which, depending on how you learned in your class, was first done with tree diagrams and then with putting in slots for things. So here's a slot for how many choices we have for president, and we have 11 different choices of people to be chosen for president. Once we've chosen who's president, we then have 10 different choices for who can be vice president, 9 for who can be secretary, and 8 for who can be the treasurer. We multiply those out however you want to, like we did below, and we get, again, 7,920 different ways that the positions can be filled. So we should say ways here, in case you have one of those picky teachers about word problems. So we're going to go ahead and move on to the next problem, and that will explain why on earth we would ever do anything crazy like this when we could have just done this. So let's move on to the next problem. Okay, for the next one, we agreed that it was going to be a combination since the order doesn't matter. Each person on the committee, committee C, president P, remember that. Each person on the committee has equal rank. So let's first go ahead and write out what the actual basic formula is for combinations, like we did for permutations. N factorial over n minus r factorial. And then we have this extra component that hopefully you've talked about in class wherever your class is. The r factorial, we need to divide out by the number of ways we can rearrange people. Up here, it was very different if Joe is president and Suzanne is vice president than if Suzanne is president and Joe is vice president. But down here, different people on a committee, it doesn't matter. So we're dividing out by the number of ways we can arrange or order the people that we would have permuted up here. So let's go ahead and write this out for C11.4. Write it underneath here, 11 factorial, 11 minus 4 factorial, and then that extra 4 factorial. Let's see what happens here. And I'll have to move up in a little bit. I'm going to move over here so I have enough space. 11 times 10, moving on. All the same stuff we had above, but now we're going to divide by the 11 minus 4 factorial, which actually I should have written out up here. 11 factorial over 7 factorial 4 factorial. So I'm going to put the 7 factorial in the same place as I did before, because it's going to have some canceling going on there too. And then the 4 factorial, I'm just going to put it over here because I can. 4 times 3 times 2 times 1. I can do that because of the commutative property, right? Because it doesn't matter which one of these comes first. Okay, so let's start some canceling. We've got the same thing we did for the permutations, canceling out. And then a lot of you are just going to stop there and be like, okay, I'm done. I just want to clean this up and be done and stick stuff in your calculator. But if you happen to have to take a quiz without a calculator, I'm going to make this a little bit more simple. Some of you will like this and some of you won't. You'll just want to calculate it out and cancel, and we'll see. So what I'm going to do here is 4 times 2. That's usually 8, right? And there's an 8 up here. So let's cancel the 8 and the 4 times 2. And then we can also look at this lovely 3 that I just put in a 3-sided triangle, and the 9. So we can cancel the 3 with the 9 as long as we replace the 9 with the 3, since it was 3 times 3. And then this time, all we have left is this, which is much easier to calculate. 11 times 10 times 3. So 11 times 30. So that's usually 330 ways. And this one, there is no magical other way to do it. All right, this was quick and dirty, but I hope it helps you remember that when order matters, or there's distinct positions or distinct prizes like gold, silver, and bronze, that it's a permutation. And when order does not matter, or it's a committee, or it's the same prizes, like if everybody wins $10, you don't care if somebody wins $10 before you or after you, you still get the $10. So, so order does not matter, or identical positions or prizes, then it's a combination. I hope you can remember the formulas, and I hope this shortcut, if you end up doing this without a quiz, helps you out. Good luck. Thanks. Bye.